Welcome to Introduction to Operations Management. Today, we explore how organizations transform resources into high-value goods and services that power modern industries. Whether your background is in business, engineering, or technology, operations management serves as the foundational operating system of every successful enterprise. Over the course of this lecture, we will examine core operational principles, quantitative analytical frameworks, and modern paradigms that define operational excellence. Our agenda today is structured around 6 core milestones. We will start by establishing the classic input transformation output framework and linking operations directly to corporate strategy and competitive priorities. Next, we will cover quantitative process analysis, including bottleneck dynamics and Little's Law, before moving into total quality management, Six Sigma, and the cost of quality framework. Finally, we will investigate capacity planning, inventory management models like the EOQ, lean manufacturing systems, and modern Industry 4.0 innovations. At its fundamental core, operations management is the systematic design, direction, and control of processes that convert inputs into value-added outputs. Inputs encompass raw materials, labor, capital equipment, and data. Transformation processes are not merely physical alterations, they also include locational shifts, transactions, and informational processing. When evaluating outputs, remember the distinct differences between tangible goods, which are inventoriable, capital-intensive, and objectively measured, and services, which are perishable, labor-intensive, and evaluated subjectively. Operations strategy acts as the critical bridge connecting high-level corporate vision with frontline execution. To compete effectively, organizations focus on 4 primary operational priorities: cost efficiency, superior quality, rapid speed of delivery, and system flexibility. Within these dimensions, we distinguish between order qualifiers, the baseline entry requirements needed just to compete in the marketplace, and order winners, which are the winning differentiators that convince the customer to select your product or service over the competition. The process design matrix on this slide shows how product variety and volume influence the right process structure. At one end are custom, low-volume project environments, and at the other are high-volume, continuous systems. The diagonal represents the best fit between product lifecycle and process choice. When a business moves off that line, it usually pays in cost, responsiveness, or both. This slide focuses on process performance and one of the most useful ideas in operations, Little's Law. The key message is that inventory, throughput, and flow time are tightly connected. The boxes below also define cycle time, capacity, and bottlenecks, which helps us understand where delays come from. If we want shorter lead times, we usually need to reduce work in process without hurting output. Quality management has evolved from simple inspection to a broader culture of continuous improvement. The top timeline shows that progression, while the bottom section connects total quality management with Six Sigma. The main idea is that quality is not a one-time check. It is a system of disciplined problem solving. Methods like DMAIC and statistical control help organizations reduce variation and defects. The cost of quality framework shows that poor quality is often much more expensive than prevention. The slide contrasts conformance costs like training and inspection with non-conformance costs such as scrap, rework, recalls, and lost customers. The 1 to 10 to 100 rule makes the point clearly. A small investment in prevention can avoid much larger failure costs later in the process. Capacity planning is about matching resources to demand, and this slide shows both the methods and the metrics used to do that. Forecasting can be qualitative or quantitative, depending on the data available. On the right, utilization and efficiency help us understand how well capacity is being used. The important lesson is that planning for design capacity alone is not enough without considering real-world constraints. Inventory management uses the ABC logic to focus attention where it matters most. The chart shows that a small number of items often account for most of the value, which is why high-value A items need tighter control. The EOQ formula on the slide helps balance ordering and holding costs. The overall takeaway is that inventory should support service and efficiency, not tie up unnecessary cash. Lean operations and JIT are built around a simple principle: Deliver exactly what is needed, when it is needed, with as little waste as possible. The slide highlights the classic 8 wastes and connects them to tools like 5S, Kanban, and Poka-yoke. The customer perspective is essential here, because anything that does not create value from the customer's point of view is treated as waste. Project management and operations deals with temporary, goal-oriented work that still has to stay under control. The slide shows the project triangle, where scope, quality, and other constraints are tightly linked. The tools listed, such as WBS, CPM, PERT, and Gantt charts, help teams plan and monitor execution. The main idea is that changing one constraint usually affects the others, so coordination is critical. This slide introduces the newer direction of operations management. On the digital side, technologies like IoT, predictive maintenance, and digital twins help firms monitor and improve systems in real time. On the sustainability side, circular operations and remanufacturing reduce waste and extend product life. Together, these trends show that modern operations is becoming both more intelligent and more responsible. The case studies compare two very different operating models. Toyota's TPS emphasizes Kaizen, waste elimination, and respect for people, while Zara's agile system focuses on speed, responsiveness, and short production cycles. The contrast helps show that there is no single best operating model. The discussion question at the bottom invites us to think about how firms balance efficiency with flexibility in volatile markets. To conclude our review, keep in mind our core pillars: transformation systems, capacity bottlenecks, quality control via DMAIC, mathematical inventory optimization, and digital transformation. Be sure you are comfortable applying Little's Law, calculating EOQ order batches, and determining utilization versus efficiency. In our next lecture, we will build directly upon these foundational concepts as we explore strategic supply chain integration and global logistics networks.